The Python library that we'll learn about in this lesson is called the Pandas library, and this provides easy-to-use data structures and data analysis tools that you can use to clean and understand your data. This is a very broad topic, so I will do my best to cover what you need to know in the context of this course. I will also make efforts to reinforce this knowledge as we get into data visualization and machine learning. An important data structure of the Pandas library is a fast and efficient object for data manipulation called the DataFrame. The image that you see below is a Pandas DataFrame. A row represents an observation, and a column represents a feature. So for example, this row is the row with index 0. This is a row with index 1, and so on. Columns can also have column names. So you have the month column, the starting balance column, and so on. Once you create a Pandas data frame, you will more easily be able to manipulate data. Now that we've gone over what a Pandas data frame actually is, let's go into how to create a Pandas data frame using Python. There are a couple different ways to do this. You can import data into a Pandas data frame, or you can create your own data, which this notebook will show. To use Pandas, you have to import the Pandas library. In this case, we're importing Pandas as PD, and we're also going to import NumPy as NP. The reason that we import NumPy is that NumPy is often used in conjunction with the Pandas library. To run this cell, press Shift plus Enter, and this will import the libraries. One of the ways to create data to put into a Pandas data frame is by using a nested list. Over here, we have a nested list, and we're assigning it to the variable car loans. We also have a list of column names, and we're going to assign them to the variable call names. We'll press Shift Enter. In the next cell, we're actually creating our Pandas data frame. We're putting our car loans data into the data parameter and our call names variable into the columns parameter. Keep in mind that if you don't know what a command does, you can always use the inbuilt help function to help you on your way. And even though in this notebook we're only using the data parameter and the columns parameter, there are quite a few parameters that I encourage you to explore. The second approach you can use to create data to then put it in a Pandas data frame is by utilizing a NumPy array. In this case, we're doing np.array, and we're assigning it to the car loans variable. And like before, we have our column names, and we're assigning them to the call names variable. The third approach is to use a Python dictionary. A limitation of creating data to then put in a Pandas data frame is that if you have a larger data set, it doesn't make sense to manually put in data, as this can be painfully slow to type. In this notebook, we're going to go over how to load data into a Pandas data frame from either a CSV or an Excel file. The first thing you have to do, as always, is import the Pandas library. The command to read a CSV file into a Pandas data frame is pd.read_CSV. I should note that this particular file is located in a relative path. It's in my data folder, and the file itself is called car_financing.csv. You can load an Excel file in much the same way, except the command is pd.read_excel. And as always, if you don't know what a command does, I highly encourage you to use the inbuilt help function. The reason why this is important is that sometimes you want to read data from one Excel sheet and not another, or you may want to skip a couple rows. After you load a dataset into a Pandas data frame, there's a couple operations that you can do to make sure that data has been loaded correctly, to check the kind of data you have, and also to check the validity of your data. One of the first things you can check is the first and last 5 rows of the data. The DataFrame method head selects the top n number of records. By default, it selects the first 5 rows. The tail method selects the bottom n number of records. By default, it selects the last 5 rows. Another good check is to check the column data types. You can check the column data types using the dtypes attribute. For example, you can wrongly assume the values in one of your columns is an int instead of a string. You can also check the shape of your data frame, and the shape is the number of rows and columns in your data frame. In this case, the dataset that I loaded has 408 records, or rows, and 9 features, or columns. Perhaps the most important method in this notebook is the info method. What this does is it not only gives you the column data types, but also the number of non-null values. And notice in the output that for every single column, except the interest paid column, we have 408 non-null values, and the interest paid column has 407. And when you get to machine learning, a lot of machine learning libraries do not handle null values well by default. This is something to keep in mind for future lessons. When working with a dataset, there are often times where you're just interested in a select subset of your data. This notebook goes over how to select columns in your dataset, as well as how to use slicing operations in Pandas. This syntax outputs a Pandas data frame of just one column. Using a similar syntax, you can select multiple columns. Please note that when you use 2 brackets, you get a Pandas data frame. You can also select one column using single brackets. This produces something called a Pandas series, which is a one-dimensional array which can be labeled. Please keep in mind that you cannot select multiple columns using single brackets. This will result in an error. If you want to select multiple columns, please use double brackets. There's also something called slicing. With a Pandas series, you can select rows using slicing. The syntax is where you have a series, you have a start index of the row that you're interested in this case 0, and you go all the way up to, but not including, the end index. In this case, it'll output the row starting from index 0 all the way up to index 9. You can also select a column using dot notation. This is not something I typically recommend. The reason why I do not recommend this is that if you try to select a column that happens to have a space in its name, you'll get an error. A safer approach is to use single brackets. You can also select columns by using lock. What the code here is doing is I'm saying I want all the rows of data. I'm interested in just the card type column. And then from here, I just want the first 5 rows. You can also use lock to output a Pandas series. One important topic when going over the Pandas library is how to filter data. One very useful method before you filter your data is to look at the value counts method. What this does is it shows you how many times each value occurs in a given column. And this is very useful to get to know your data set. What the code here is doing is it's creating a Pandas series of true and false values. You'll have a true for a given index if the value is Toyota Sienna. You'll have a false if it's not. And then it's assigning it to a variable. One approach to filter a data frame is by using square brackets. Another approach is to use LOC. If you look at the output of this command again, even though it looked like we were filtering for a Toyota Sienna, we didn't update the original data frame. You could update the original data frame by assigning it back to the original data frame. And as you see, we have filtered out all the cars except for Toyota Siennas. What this code is showing is that you can also make a filter for different columns. For example, if you want to filter out all non-7.02% interest rates. And finally, it's important to note that you can use multiple filters in conjunction with each other. You can do this by utilizing various bitwise logic operators. In this case, it's an AND filter. The Pandas library also offers the ability to rename or delete columns from your data frame. There are 2 popular ways to rename data frame columns. You can use dictionary substitution, and this is very useful if you only want to rename a few of your columns. There's also list replacement, and this requires a full list of names, and in my experience, this is a more error-prone method, as even if you just want to rename one of your columns, you have to include names for all your columns. Here is what the data frame looks like before renaming columns. Say I want to rename the principal space paid column. One way to do this is by using dictionary substitution with the rename method. So I have my data frame name, in this case it's called df. I do .rename. I'm inputting a dictionary into the columns parameter. And what this is doing is it's changing the starting space balance column to the starting underscore balance column. And similarly, for the interest space paid column, it's becoming the interest underscore paid column, and so on and so forth. And as you can see, the old column names are gone, and they've been replaced with the column names over here. Another way that you can rename columns in Pandas is by using list replacement, where you have your data frame name, the columns attribute, and you're assigning a list to that, and of course, you can also delete columns. In this case, I just want to delete the column term. And the second approach to delete a column is by using the del command. When working with the dataset, it is often a good idea to compute summary statistics. This can tell you if your dataset is skewed, what your outliers are, and more. What this notebook shows is a summation of the interest paid column for a particular loan. As usual, we import our libraries. The rest of these commands are just building off the previous notebooks. And all we're doing in this notebook is applying a sum method on this Pandas series. And this gives us the total amount of interest paid over the course of a loan. You can also sum all the values across all the columns. One thing to keep in mind is the reason why this looks really weird is when you use the plus operator on strings, they concatenate. An important point to emphasize, for this particular method, it ignores nans, in other words, missing values. If you don't know how a particular method or function works, I highly encourage you to use the inbuilt help command. And one last point for this notebook, notice that every other column except the interest paid column has 60 values that are non-null. So in the next notebook, we'll see if we can understand this missing value, fill it in, or remove it. One of the most important reasons for learning the Pandas library in the context of this class is the ability of Pandas to identify missing data. As usual, with most of these notebooks, you first have to import your libraries. We're going to run similar commands to the previous notebooks. This is just loading data, filtering, renaming columns, etc. As you saw in the last notebook, we're using the info method just to verify that we have some missing values. We'll find a better way to identify the number of missing values later on. There are two common methods to identify where values in a data frame are missing, and those are isNA and isNull. They are exactly the same methods, but with different names. What the code here is doing is we have a Pandas series. We're using isNA, and what this does is this will give us another Pandas series of true and false values. If we have an NA or a null, it'll give us a true. From here, I'm just looking at the first 5 rows. And we're taking a filter here, and we're making it into a variable. This code will show us where the value is missing in our data frame. And as you can see here, we don't have an interest paid for a given month. And in the context of this data set, this can be a problem as we're trying to find the total amount of interest we're paying over the course of a loan. Having an NA here and ignoring it means that we're not counting some interest if this happens to be a data error. If we just want the rows that don't have missing values, we can use a logical not operator. And of course, if you want to see what this does, just put another cell, press Shift-Enter, and then you see the output is the opposite. What this code is doing is we have our original Pandas series. We're using isNA to get true or false values. If there's a true for a given index, that means there happens to be a missing value. If it was false, that would mean that you don't have a missing value. And then what sum is doing is it's summing up all the true and false values. And the reason why this is 1 is that when we go down a Pandas series and we have a bunch of true and false values, Booleans in Python are a subtype of integers. So a 1 is a true and a 0 is a false. And all this really means is that we're just manipulating a property of Booleans in Python. In this notebook, we'll go over how to remove or fill in missing values. As always, we have to import our libraries. These commands below are just loading our data, filtering, renaming columns, etc. Like before, the info method is just showing us that we have missing values. You can remove values by using the dropNA method. Here is what our data frame looks like with the missing value. As you can see, for this particular index, we have a missing value for interest paid. DropNA with the parameter any will remove an entire row if it happens to have a missing value. As you see here, we're missing the row with index label 35. There are many different ways to fill in missing values. One way is to fill in the nan with a 0. In this case, it's probably a bad idea, as it looks like we're missing some sort of trend with the interest paid for this given index. It seems like this should be in the middle of this value and this value, roughly at least. You can do a linear interpolation. And as you see here, index 35 is now roughly between index 34 and index 36. Now let's look at the interest paid before filling in the nan with a value. The actual value is outside the scope of this course, but I'll leave a link in case you're curious about how this was calculated. For the interest paid column, and where you have a missing value, we're going to fill it in with the actual value. From here, we're going to look at the interest paid after filling in the nan with a value. And as you see, this is a higher number than this number. So previously, when we used the sum method, we were undercounting the interest paid for a given loan. And notice when we do info again, we have 60 non-null values for every column. And the reason why this really matters, especially in the context of this course, is that a lot of algorithms do not deal well with missing values. So understanding your data is important, manipulating your data, and also finding ways to deal with missing values or values that could be misinterpreted is really important. In this notebook, we'll briefly go over how to convert your Pandas data frame back to a NumPy array or a Python dictionary. The reason why we're covering this is that there could be occasions where a machine learning algorithm would not accept a Pandas data frame as an input. It could, however, accept something else, like a NumPy array. As usual, we first have to import our libraries. We're loading our dataset, filtering, etc. To convert a Pandas data frame to a NumPy array, you have your data frame name, and you use the toNumPy method. You could also use the values attribute. While it may not be probable that you'll need to convert a Pandas data frame to a Python dictionary, it's just worth knowing on the off chance that you do. And to do this, you can use the to_dict method. In case you're interested in exporting your Pandas data frame to a CSV or Excel file, this notebook will help you do it. As usual, we're importing our libraries. The command to export a data frame to a CSV file is the data frame name and to_CSV. This is the file name. I'll be putting it in my data folder, and the file itself will be called table_a_few_things.csv. What index equals false means is that we don't want to export the indexes of our data frame. We just want the column information. If you're not sure what something does, I encourage you to set index equal to true, see the output, and set index equal to false, and see the output. What you see on the right side of the screen is the output of the to_CSV command with index equal to false. If I then make index equal to true, close the file, and then look at it again, you'll see that we exported the indexes as well. You can also export your data frame to an Excel file by using to_Excel. This is the name of the file, and in this case, I'm setting index equal to false. In this lesson, we went over a couple things that the Pandas library can do, from importing data, to cleaning data, detecting missing values, and more.